The ship is just new in salt water just this last week. It was built in Wisconsin in Marinette Marine Corporation, and we brought it out through the Great Lakes last week. We have a wonderful GPS tracking system on it that's set up for a desktop view, so everybody in Fairbanks, the University of Alaska Fairbanks and everywhere else has it as their screensavers. So we watched it through all the locks, come through the locks last week, through the St. Lawrence Seaway, stop in Montreal for a while, come around the corner, and came here to Woods Hole because this is one of the UNOL's, the national fleet for vessels. This is one of the major ports. And with their gracious host with us for this last week, we're putting cable on board, doing lots of instrumentation and calibration work, and getting it set up on its way. And from here, it'll continue on its science mission. So the name Sikouliaq is actually an Inupiat Eskimo name, which, you hear the story, there's 100 words for snow, 100 words for ice. This is true. And in this ice, Sikouliaq means first-year sea ice that is safe enough for man to walk on, which is literally the type of ice that we can work in. And so it's the only vessel in the whole U.S. fleet of research vessels that is ice capable, which means we won't run away from the ice. If we see ice, we can head towards it. We can work in the pack ice. We can work in fairly heavy ice. But the ice pack, the melting edges on it, would be totally at home in that kind of ice.
Anyway, the Sikouliaq is a general-purpose oceanographic research vessel that's designed with for ice-capable research in the Arctic. So it's not an icebreaker, but it's ice-capable.
1 meter of sea ice pretty easily. So a little over a yard of ice we can go through pretty easily. So we're not classified as an icebreaker because you've got to be able to handle more ice than that. So we're ice-capable, and we can cut the ice, but we slice it and then split it and go through it. The icebreakers are designed by the Coast Guard for Coast Guard purposes, and we sort of rent them from the Coast Guard. If they have another mission, they've got to do that. I mean, their job's the Coast Guard. This ship designed from ground zero as a science support operation in order to be able to handle the ice. Once you see it, you'll understand it is totally dedicated to science. So it's not an icebreaker that we've rented for science purposes, and they've been fabulous. They're really, really good. They can go places we can't. But this is designed from the ground up by scientists for working in this type of environment. Now, it's a global class. You can go anywhere in the world. In fact, the first 2 cruises are in the Central Pacific, but it's designed for ice.
With everything occurring north, this is extremely important in terms of research. In the course of about 10 years, there's a 9% decrease in ice because of global warming and other issues. But that reduction has opened up more areas for research, and it gives us an opportunity to find out what's happening there. They're able to look at and trace the effects of global warming and some of the environmental issues that are occurring. They're also, which is important for our region, able to do work that will affect ocean mammals and fish and determine what's happening as a result of some of the climate changes that occur and some of the changes that are there. Also, they're able to do work, which is very important, through sediments and looking at underground volcanic activity and other things which could really be helpful in the time of some kind of seismic catastrophe that would lead to a tsunami. Even getting a few minutes' notice would be critical to saving lives.
That ice edge is where all the really important biology and human interactions are going on, right there at the ice edge. Whether that's for shipping purposes, whether it's for the millions of people that live above the Arctic Circle and how they make their living on the ocean, or geopolitics, or whatever reasons you want. It's right there at that edge where the ice is forming and not forming every year, where all the action's occurring. And this is exactly where this ship is tuned to be. So whether it's questions of polar bear biology, whether it's questions of how a ship's going to come through the Northwest Passage, whether it's questions of exploring as the ice melts, what happens to permafrost and the communities that have been on these coastal villages for 5,000-10,000 years, as that all changes, that's exactly what we're going to be.
The Coast Guard mandated crew on this ship is 20. has about 24 science berths on it and 2 technicians, which are we consider part of the ship's complement, because what makes it a research vessel is the fact that it has all the instrumentation on it. Otherwise, it's just a ship, right? So there's the other key department on these is the technicians department, and and they run all of the ship's acquisition systems. The systems actually collect the data.
When I first started sailing on the Sikouliaq, an NSF-funded research vessel, I only had 3 computers in my whole lab, and I think if you look around, I have a few more than 3. So right now I'm serving out about 300 IP addresses to all the different systems on board that are science-based. And yet we have quite a few other things that are computer-based, like telephones, camera systems. The bridge navigation system is a whole computer-based system now. So things have changed. We have quite a bit of sonar gear on board the vessel, which I didn't have on the older vessel. These are systems that have developed recently. We have EM 710. This is our shallow water multi-beam system. As you can see, this is actual data we took. It's just coming over the Andrea Doria shipwreck, and we were able to see it on the multi-beam, and it looks very similar to what you would see on a side scan sonar. I also have a hydrophone array that we monitor under the vessel. So we have 6 hydrophones under the vessel looking for underwater radiated noise. This might tell us if we have an issue with some rotating gear. If there's a nick in the prop or something, we should be able to tell it from this system here. We also have a center board with additional acoustic package on it. So the center board deploys about 10 feet below the vessel. This allows us to get the sonars below the bubble sweep that rides along the hull. And the bubbles are really bad for sonar, so we want to extend it down and get clear of that. The sonar system we have on that board is the EK60. I also have a camera in there to look at what type of bubble sweep we might be giving on the hull right now. And I also have acoustic modem in that center board.
The other thing that this has, it's all broadband connected, although I guess when they're up in the Alaskan area sometimes there's problems with our Verizon, but they're broadband connected and they can connect and create virtual classrooms for other scientists here and in other places so that they're working outside the vessel itself, getting the same information to research and to learn from. So there's so many benefits to this that have been lacking. And this is an opportunity here to do this thing. We're able to advance not just in the quality of the vessel in 40 years, but what it can do. Really, I asked how many other vessels are like this in the world, and their answer was none.
The ship is diesel electric, and what makes ships so complicated these days is everything is computer controlled. What I was talking about, the dynamic positioning system, but also all of the main engines, all of the systems are all controlled by what's called a PLC, Programmable Logic Controller. So if you open up these consoles, there's a bunch of little boxes with blinky lights. Everything's controlled by a computer these days, including ships. It makes it very complicated to run, or very, very complicated to maintain. But also it makes it very efficient, very capable. So it's just where things are these days. So it's diesel electric, which means that there's diesel generators that produce electricity, and then everything from there is all electrically driven, including the main propulsion motors. There's 2 large electric motors down there that drive what's called azimuthing drives, which turn 360 degrees. That, combined with a bow thruster, makes the ship incredibly maneuverable. The ship can actually walk sideways. So there's no rudders on this ship like a conventional ship. It can twist in its own length. It can stay on one geographic location for an extended period of time, really indefinitely, days and days and days, while it's servicing science instrumentation on the bottom. So it runs on diesel fuel, essentially.
The ship does not have a rudder, and it's so you go, okay, how does it steer? What you could see are 2 underneath, 2 totally independent propellers that are on what are called Z-pods, so they can rotate vertically in any direction, they can point any way, and they can spin in either direction. And we have bow thrusters on the front, which are pumps, essentially, to punch water. So if the ship could essentially spin on its own axis if it needed to do that, and be able to maneuver and work its way through the ice.
Actually, driving a ship with a new rudder is just, once you have the fundamentals of ship handling down, it's just a different application of, the principles. So you go through training and you basically train that, you get the hand-eye brain coordination, buttonology of the ship, and it becomes a thoughtless process. It has to be. Well, two Wärtsilä ice pod C drives, and then the one azimuth. They're all azimuth things, so they all move 360 degrees. And so the difference with thrusters compared to like a conventional rudder boat, when you want to go left, you kind of turn the rudder left. This is like when you want to go left, you turn the propulsion thrusters right. So it's just a function that you learn. Left is right, right is left. When you move the combinators, I mean, ultimately, I guess they could do a thing where they would reverse the technology to do that. It would just go the same way, but it's how they're designed. Is that when you work with thrusters, you see the C drives, or the Z drives, as they're called, you move in the opposite direction of what you would normally do. Once you know that, you do that. But some people that come from conventional ships, they have a period of time where that's an adjustment because when somebody gives them a right rudder command, they think you turn to the right, not as opposed to turning to the left. So it's like you have to just watch some people initially when they do that transition. But the 360-degree azimuth thrusters, they have some things too where you have to learn not to start the propellers, so you can't aim the thrust at each other. You can't, there's certain you can't bring them across each other and things like that because you'll start the propellers and you cause cavitation in the hull. So there's around the props because the propeller design needs water to draw, and so if you just take away the water, then it causes cavitation problems. So there's just subtle things to learn not to do.
As best we can, it's not fully ADA compliant, but to the maximum extent possible, we've made it as accessible to the disabled as we possibly can for disabled researchers. So you'll notice coming down the ladders, there's those tactile strips, those things that you touch, like you see on the edge of a train platform. You can feel when you're at the bottom of a ladder. So someone who's visually impaired would know when the bottom of the ladder was. And these are just for opening and closing the doors for someone that's wheelchair accessible. And the clear width on these passageways said that a wheelchair can actually navigate through here. And there's actually a statement forward that's ADA compliant where someone in a wheelchair could access the whole main lab, the whole main deck. In a wheelchair and be able to do their science. The great thing about it. The interesting thing about it, though, is what's important is that obviously it does take some extra effort to make a ship compliant. It takes some thought up front about where you're putting doors, how you're doing passageways. There's an elevator that can actually get a wheelchair right over here up to the mess deck. So the main deck and the O1 deck are the two that are ADA accessible. But the reality of it is it makes it a lot better for other people too. Just having, for example, if you're a scientist carrying water samples or get something in your hands, it's awfully nice to hit the button and have the doors open for you. It's just like on the metro, right? When you're carrying your bags to the airport, it's nice going through that wheelchair compliant gate instead of the regular one because it's wider, right? So even though it's an investment and there's not many disabled researchers that sail on these ships, it does make it better for those that aren't. If a disabled researcher were awarded a science grant, they might actually then in the ship's scheduling system request the Sikouliaq because they know it's ADA compliant. So it doesn't affect the selection of science or where the ship goes, but the selection of the platform used to do that science might then be driven by its accessibility.
The next step is it's still under trial, still under warranty, just like when you buy a new dishwasher, you got a year warranty, right? Well, we've got a year warranty on the ship, and so it is headed off into out towards San Juan next. It'll do some work around here next 3 weeks, back here for some fueling, heading off towards Puerto Rico for some deep water trials through the Panama Canal in mid-September. And then the first 2 science cruises are actually in the deep Pacific, out at 4,000 meter, almost 2 miles deep out in the Pacific, working at some seamounts out there. And then it'll work its way to Alaska, come up through the inside passage there and into Seward, where it's its home port, and right around the first of the year. And we will be commissioning it in February in Seward, so you're welcome to come into February in Seward. The weather will be awesome. We take it into the Bering Sea in March 2015 for ice trials, and then as part of that warranty period, we have to dry dock it afterwards to see how the hull did with the ice. And then fully, totally open for National Science Foundation and other agency-funded research roughly next May or June.